In this recording, I'll explain what's happening in this Git repo, where you're going to find 4 projects, all of them related to using AI agents in Temporal and having access to tools available either through MCP, Nexus, or a combination of both. You should see in the description the timestamps to jump straight to each one of these projects as needed. But before going there, I'm going to do a quick introduction of why I created this project, when it makes sense. Feel free to skip if you're already familiar with this. So a temporal introduction. Slideshow. Why temporal was created? Why does it make sense? Usually you have a application that has an objective like process and order, and this is composed of multiple steps, the workflow. So in the example of processing order, you're going to check fraud, prepare shipment, charge customer, and ship order. When you bring this to production, you find out that there's going to be a lot of externalities that are required for this to work. You're going to connect to external database, external resources, and in order to do that, you start to introduce queuing systems. You might have schedulers and cron jobs. You're going to have to codify retries for the different failure scenarios that you envision. You're going to have some sort of state management. And what we find is that all of this eventually is going to fail. Network might not be available, process might fail. There might be some bugs in these plumbing codes. And with this, you get to a scenario where you're going to have a combination of business codes, the things that really make sense for your application, and all these plumbing codes that's pretty much reinventing the wheel, trying to solve these problems that have already been solved millions of times. So that's why Temporal makes sense. It allows you to decouple what's the business logic part of your application, and you can leverage the Temporal SDK abstractions available for the different programming languages, Python, Go, TypeScript, Java, .NET, and others. And the plumbing code, all these retries, the queue, keeping track of state, you can let become responsibility of the temporal service. So temporal service is going to be this server that it's pretty much works as a fancy database that helps you keep track of the state. So if there's failure in any one of these steps, once the failure is remediated, so the application is ready to run again, you can resume from where it was interrupted without losing the previous work. So what we find is that in a situation before Temporal, you're going to have the majority of your source code being plumbing code, things like these retries, managing queues, etc. And with Temporal, you're able to overall reduce your source code, and the majority of it is going to be the core business logic, and plumbing code is greatly reduced. How does this work? Temporal, you can think of 3 different elements that are operating. You have the temporal service, so it's this external database, a little bit more sophisticated than that, but you can think of what's keeping track of your state. You're going to have a client, so something that triggers the execution. And then you're going to have the worker. So this is the process that's actually executing whatever your application needs to do. And you can scale your worker up or down based on your needs, your demands. So you're decoupling the plumbing logic from the business logic. It makes it also easier to control the scaling of your application. And the worker is run in your environment and temporal service, and the client can be in different environments. They don't need to know about each other. Mostly the temporal service is there to help your application keep track of state. So this is the basic of temporal. When you go into AI agents, we see it as just another form of distributed system. So instead of processing the order with multiple steps, now you're going to have a dispatch agent or an orchestrator that receives the initial query, sends to an LLM with a prompt specifying that perhaps you have different tools, different specialist agents available. So this orchestrator is going to select one of these And these different tools can be a reg tool, or it can be a tool available through an MCP server, an external API call. And when you want to make a system like this durable, you're going to face the same challenges as what I described before. You're going to have retries and timers, etc., that can fail. So the plumbing code you can delegate once again for Temporal. So even though Temporal requires the workflow, the application to be described in a deterministic way, and traditionally AI agents you're using to be non-deterministic, so you don't know how many steps, how many tools the agent is going to support, it's still possible to codify this for Temporal, and this is what the demos are going to show. So this is a very well documented pattern that Temporal supports really well. So that's Temporal for AI agents. And usually when you start deploying, Temporal also has the concept of namespaces. So you can start your agent, your durable agent, using Temporal in one namespace. But eventually, as the use of Temporal spreads across an organization, different teams are going to start using different namespaces, and you might start to see duplication of code of these AI agent systems. So how do you do if you want to ensure that the code can be shared across the different sides of your organization? Well, Temporal has a solution for that. It's called Nexus, which is RPC durability layer, meaning it supports remote procedure calls from one namespace and it routes to another namespace. That way you don't have to recreate this AI agent for every namespace. The different departments can just expose the tools that they want to make available, and it's a better approach to governance in enterprise. And Nexus is a very robust solution. It sits, if you think about the Temporal server, in the self-hosted is going to be global per cluster, and in Temporal Cloud is going to be global per account. And you're going to create Nexus endpoints with the different endpoints you want to expose. And these endpoints are going to point to a namespace and to a task queue. And the way that one side is going to communicate with the other is using the service contract. So it's kind of like an API endpoint, but you specify what you are exposing in this endpoint. So both sides know how to communicate at a high level, but they don't need to know the implementation details. And Nexus is a very secure solution. It follows the pattern of zero trust. So mainly in Temporal Cloud that has the authentication authorization layer, it's going to use TLS certificates to connect to the different namespaces internally. It uses Istio. And for every endpoint, you can create an allow list of what are the namespaces that can access that particular endpoint. So the idea of Nexus is to allow you to reduce the blast radius, because now you're compartmentalizing these tools in different namespaces, but you're still exposing them, so you can have control on the governance of what's available for the organization. And Nexus supports the full temporal durability guarantees. Finally, Nexus has a really cool feature when you go to the Temporal UI and you see the different steps of execution. You can click in one of these steps and it goes straight to the namespace if the user has permissions to view that namespace. So this is a Temporal Cloud feature because it has that authentication layer, but can be implemented in the self-hosted. Great, so let's go to the first demo. This one is the Light LLM underlying Temporal. And what we're doing here, there's 4 terminals that are going to be open. One has the client, the other has the orchestrator worker. There's one for the IT Nexus worker and one for the finance Nexus worker. So what I'm trying to represent here is that imagine we are in a large organization and one department is responsible for IT, so they handle the IT namespace in Temporal, and they're deploying this Nexus worker to expose two tools that they want to make available to this agent. One of these tools is going to retrieve the IP address, and the second tool retrieve the status of a Jira project. And the other team in a separate computer, separate department, they're doing the same thing, but for the finance. And there's two tools, one for checking stock price and the other for financial calculations. And what this is going to show is using Nexus as the bridge between the orchestrator worker and having access to these tools in two different departments. And Nexus is responsible for facilitating the authentication and authorization. And you see that what's required from the orchestrator side is to have access to the models and to the services related to these applications, to these tools, but it doesn't need to know the specifics of the tools. So this is traditional in enterprise environment. You need to have some type of agreement of what's going to be available from the two sides. So let's go to the demo. It is... Oh yeah, I was right. It was here. Cool. So we have the temporal server running here. And you're going to see in the README, there's these instructions on how to create the namespace on a new server. So I'm going to create here. So you create two namespaces. And then you're going to create the two endpoints, the Nexus endpoints that we're going to use. The Nexus endpoints, you just specify what's the namespace and what's the task queue that you want these endpoints to be associated with. Because once the orchestrator sends a task to Temporal, is going to send to this task queue as a Nexus schedule task start task. And the Nexus handler on the other side is going to be listening to the same queue for these types of quests, tasks. So we have this here. Then we're going to initialize the finance worker, which is, this is correct. Yes. And then we're going to initialize the IT worker. This is the regular orchestrator. Oops. And over here, we don't have MCP servers yet. So once again, going back to the diagram, we have the orchestrator worker, the IT Nexus worker, the finance worker, the temporal server with these namespaces and endpoints created. Now let's just initialize the client, which is here. Great. So now let's ask a question. What is the stock price of Amazon? And we can see here, if you're familiar with Temporal UI, what happened. So there was this Nexus call where the agent identified here. It received this information and it knew that it needed to execute a remote tool, and I'm going to show on the code how we knew where to call, but it called the stock price, and this is the Nexus call, and now it's waiting for the next output. You can see here in the US it shows the different endpoints and how many workers, if any, are listening at these endpoints. So going back to the code, let me show what this code is doing. A cool thing about this code, in contrast to the next one, is that for this one we are using, for the AI agent, is implemented in pure Python. So to show how you don't need to rely on frameworks, and you're going to see this in the app workflow. So you're going to see a lot of code here. There's this process message. So this is receiving the message and keeping track in a history. So this is the context that the agent is going to use. This is the command we are making available to execute the Nexus tool. And you see that the agent, well, because for this first example, the tools are static. So we have created these specific Nexus endpoints that the tools are available. And the way that we are interacting with this AI agent is through this update. So the client can send an update message, and where's the while loop is going to be here. So this is the main agentic loop. So it's always planning for a result. And if it reaches the conclusion that it should execute the tool based on the prompt, that's how it knows how to go next, then it calls this activity execute tool, because all of this is inside the workflow. And then it's going to append to the event history. This is if it's a local tool or a tool that's available through Nexus. And I'll show the prompt in a second. And then it's appending. And then if it received the signal that the session is done, then it knows that it should close. And the prompt is going to be here. So it's a regular workflow, and in the activities, I'm going to declare the local tools that are available. There's 2 local tools in addition to these 4 remote tools. And here in the prompt, I'm telling it to use the remote tool or the use tool, depending if it decides to use the local or the remote. And you're going to see here, like once again, is static, not only the Nexus endpoints, but also in the prompt, we hard code what these tools are. This is a situation where you already have a mature workflow and you don't plan to add new tools. It's the first step. But the main thing about this is to show how you can implement this AI agent using pure Python. So my recommendation is check this workflow. And also I'm using Light LLM. So you can select, and everything related to LLMs is in this LLM client class. So you can specify in your environment file. This is an example. If you want to use OpenAI or Anthropic, Gemini should be supported as well. I haven't tested, but feel free to provide feedback. So this is the first example. Now let's jump to the second one. The second demo is going to be this OpenAI Temporal. Let's go to the view. And this is very similar to the first demo. The only difference is that we're not going to implement the AI agent using pure Python. Instead, we're going to use OpenAI Agent SDK integration with Temporal through a plugin. So you're going to see that it's a much cleaner source code, because we don't have to worry about context and specifying explicitly making the connection to the Nexus endpoint, because we can leverage the functionality from the OpenAI Agent SDK. So you're going to see here the main difference. We're still going to have the while, the main while, but you're going to see it's a much more condensed code than before. And here you can see this Nexus operation as tools. This is what is the OpenAI Agent SDK integration with Nexus that comes out of the box. So it becomes much simpler than the other one. We can do a demo just to show it's going to be the same. So I'll stop this guy here. The and it's the same command. So it's a matter of preference. I just wanted to make sure to show the 2 options. And even though I'm using the OpenAI Agent SDK, I'm still using, it supports Light LLM, so you're still able to choose your LLM provider as long as it's supported by Light LLM. We're not using MCP servers here yet. Here, just stop the client to make sure we're using that one. And there's no difference for the temporal server. Similarly, if you miss the first part, you should check on the README. There's instructions on how to run the, you have to create 2 namespaces and 2 Nexus endpoints for this demo to work. You run the client, and here you can ask questions. What is my IP address? And it's going to return a hard-coded command, and we can see the Nexus call over here in workflows, second workflow. So this is where it got the IP from Nexus. So once again, just to finalize this presentation, this is what's happening. The orchestrator worker is able to leverage these tools through this Nexus endpoint. So this is how we statically define these tools, both on the prompt and as tools that are hard-coded. But what if you want dynamic tools? That's when you go to the third demo. For the third demo, we're not going to use Nexus. We're going to use traditional MCP servers that are going to be exposed as HTTP server and also STDIO. Our AI agent is going to connect using HTTP transports. And the idea here is to leverage the traditional benefits of an MCP server that you can dynamically discover tools. So because of that, in the AI agent, in the orchestrator, we are not going to hard code the remote tools in the prompts, and the orchestrator doesn't need to know anything. And well, we're not going to use Nexus endpoints. So this HTTP call, there's not going to be durability guarantees, and we are not leveraging Nexus authentication and zero trust policies. You can implement this as part of your MCP server, but this is external to Temporal. Having said that, in the MCP server, we're still calling a Temporal workflow. So it's just kind of like another Temporal client that has its own durable execution. So for the tools that are exposed through this MCP server, they're still going to have the durability guarantee. It's just this call made to the MCP server that's not going to be durable, meaning it's not going to be stored in the event history. And for this implementation, we're also leveraging the OpenAI Agents SDK, because as we saw from the first to the second demo, it greatly simplifies the source code logic. You don't have to worry about keeping track of context, and also there's some great MCP server integration. And about that, a cool feature, if you look into the AI Agents SDK documentation in the MCP section, it has these list tools, and by default, every time that the agent makes a request, it's going to refresh the tools available. This can be configured where you leverage a cache instead, because potentially there's a performance hit if every time you need to make this request. But we are going to use this in our demo to show that once you add a new tool and you restart the MCP server, it's going to be available to the worker. So let's see what this looks like. We are here, so just run the worker. And this time there's no Nexus in the file name, it's just the worker. MCP orchestrator. For the MCP server, oh yeah, this is the first time we're actually, so instead of 5 terminals, we added 2 more for the 2 MCP servers. And the way that I have coded here is described in the README, you can see. Just make sure that you do Python-m, so it calls the modules correctly. So this is for the IT, and this is for the finance. Oh, I'm sorry, cd open uv python, no, uv python, this is the finance. Oh, but I don't want Transport Studio. I could pass like HTTP, but it's already the default. Finance. Did I do things? Oh my God, I'm sorry. IT. And this is finance. Cool, we have the two MCP servers running, and now we run a new client here. CD. Same thing. What is Amazon stock price? It's just, I could have asked for the tools, but it does lazy initialization, but now I can ask what tools do you have available, and it's going to tell me the two local tools and here the two local tools and the 4 remote tools. So now let's add a new tool to the finance, and in order to add a new tool we are going to finance here. So I'm going to uncomment this in the MCP server and save. And so this is a very simple tool. If it were in reality, we also would create a new workflow entry and a new activity if we wanted to make this durable. But here for this new tool, I'm just creating a new tool name and I'm and a new tool description so the LLM doesn't get confused. But I'm just leveraging the same thing just to show that over here is going to show 3 tools. So I have saved this and I'm going to redeploy the finance MCP server. And redeploy. And then in the client, so what tools do you have available? We should see there's a new tool that's available for finance. Here, this retail eval. So this is to show if you want dynamic tool discovery and you are not as concerned of using this HTTP access between the AI agent and the server, it's available. And once again, this magic is happening because this is from the OpenAI agent SDK that by default has this behavior of every time refreshing the tool list. If you're not using the OpenAI agent SDK integration, this is just something that you have to make sure that you're implementing or see if your framework supports that. But now let's go to the 4th and last one. Okay, so if you just arrived here, this is the 4th demo of this GitHub repository where we are going to combine everything that we have presented so far. We're going to use OpenAI Agent SDK, we are going to use MCP servers, and we're going to use Nexus endpoints. The main difference here is that we're going to see it's a little bit trickier to do the dynamic tool discovery, but it's still possible. But the idea here is this makes sense if you're an enterprise that's really cautious about the durability of the entire process. You want to make sure that the calls to the MCP servers are durable, that they are stored in memory, and you can leverage the security benefits of using Nexus endpoints. But if you got a chance to see the previous demo, you saw that to introduce a new tool, was just a matter of updating the MCP server and restarting the server. And because we were using the OpenAI agents integration, it was available right away. But here it's going to be a few more steps that are going to be necessary, because when we use the Nexus endpoints, you have the service contracts. So you need to make sure that the service contracts are updated. So in the demo, it's going to be simple. We just update in one place. But the service contract needs to be available for both the orchestrator and for the MCP server. So let's see what this looks like. This one. So let's stop all our processes so we can switch. And stop the clients. Oh, and once again, if you just started here, make sure that you have your Temporal server running and that you have run the created the namespaces and registered the Nexus endpoints following the instructions on the README. So here, cd Nexus MCP, and this is the, is it called Nexus worker? And here, instead of MCP servers, we're actually going to deploy gateways. Nexus. So the way that this works is a community contribution of somebody that works for Temporal, but to say that it's not officially supported. But we are leveraging this dependency that's called Nexus MCP Python. I had it open here. Nexus, this one. So it's this Git repository. If you read the README, it's going to reference. So this is what we're going to use that has this magic to expose the MCP server MCP protocol primitives through the Nexus endpoints in a transparent way. So we are here, and we are going to call the, this is the IT, so it's simple, UV run IT gateway server. And this is not a traditional MCP server, so you won't be able to connect with Cloud Code or Goose. And there might be changes soon, but this is just as a reference if you need to have this kind of durability guarantees for your AI agent using MCP servers. CD Nexus UV run. This is the finance. Gateway. And the client, run client, yeah, same client. So let's say what tools you have available. So that's to show the lazy initialization. It's going to show me the generic information that's available. Oh no, it already picks up. So it shows these tools, and we can ask what is my IP address. So it was able to retrieve, and if we go to the UI, workflow, this new workflow, this is where it listed the tools, and it got the IP. So going back here, what I'm going to do is, what is the process to add a new tool? So what we are going to do is in 3 places. We're going to go to the activities, and we're going to add a new tool here. And this is because of the worker. And we're going to go to the Nexus handler. Usually this is the only place that we need, but because we need also the worker reference, so I'll save here. And then the service. So as I mentioned, this is the contract, and both sides need to know what to expect from this Nexus endpoint. So you need to express that there's this new tool that's going to be available. So once you have done that and you have saved, you can redeploy the, we changed the finance gateway. And you're also going to do this change on the worker. So it's it knows how to pick up, so it's correct. Otherwise, like it might show, but it wouldn't execute. So just to make sure, we saved, and we are redeploying the worker. Finance. And because we changed the service agreement, we need to notify the client, the orchestrator actually, that the service has been updated. And in order to do that, you can restart this orchestrator, which is not ideal. Or I have implemented here a signal, so you can send an update requesting the worker to refetch the tools that are available. Because if you were to ask the client now, so what tools you have available, it's not going to show this new tool yet. Yeah, so see, there's only 2. But if you go to the README, it has the commands. Yeah, so you can find the command here. You just need the workflow ID. So let's get that from here. It's this guy. And we can update here. And we just run this. So I'm sending this signal that I had configured. So it's going to tell the orchestrator to retrieve the new tools. So what tools do you have available? It should show the new tool yet. Here, a new tool for testing calculators, and previously it didn't show. So this is to show that, going back to the diagram, it's similar to the previous one, but now you get the Nexus and temporal durability of this call. You're not relying on the HTTP call. However, where for the MCP, to add a new tool, you just change the MCP server. Of course, like if you want it to be durable, you change the workflow and durability, but just the server itself, it's what needs to be exposed. Because we're leveraging the OpenAI agent's SDK behavior, that it lists tools every time, so it's more straightforward. Versus using Nexus, you actually have to change the definition in the models, in the service, in the workflows, and in the handler. And then you have to either send a signal or stop and start the AI agent again. Hope this helps. Let me know if you have any questions. Thank you.